So hello everyone, good evening to one and all. So here in today's session, we are going to revise the mole concept and stoichiometry concept, and we are going to solve some previous year's questions on this topic, okay, of JEE and NEET. So moving on to the first part, that is the mole. So what is a mole? So 1 dozen is equal to 12. We all know that, right? 1 dozen is equal to 12 bananas, etc., etc. And 1 mole is equal to 6.02 into 10 to the power 23 particles. That particle can be atoms or molecules or electron, proton, neutron, etc. And now this number, we all know that this number is called as the Avogadro number. So 1 mole is equal to the Avogadro number of particle present in it. Right. So this is about the mole. And coming to the empirical and molecular formula. Empirical formula is the formula of a compound that contains atoms in simplest ratio. But molecular formula indicates the actual number of atoms in one molecule. Right. So there is a relationship between molecular formula and empirical formula that you can see. So molecular formula is equal to n into empirical formula, where n is the positive integer. And that n can be calculated from the molecular formula mass and empirical formula mass. That one of them will be given to you in the question, and from that you can find out the value and you can multiply that number to the empirical formula and find out the molecular formula. Okay. So these are the relations that you have to keep in mind to find out the molecular formula from the given system. So now we will solve one example on this. I will tell you how to find out the empirical formula first. Suppose if the question is like this. A compound contains 4.07% of hydrogen, 24.27% of carbon, and 71.65% of chlorine. Its molar mass is 98.96 gram. What are its empirical formula and molecular formula? So here you see the first thing that you have to do is we have to do the tabular method for the calculation of this empirical formula. So first, you just take the elements that are given in the question. Here in this question, we had hydrogen, carbon, and chlorine, right? And the percentage composition is given there in the question that we have to take. And next, we have to write the molar mass of the element. So we all know the molar mass, the atomic mass of each element, we all know. For hydrogen, it is 1, and for carbon, it is 12, and for chlorine, it is 35.5, and if it is nitrogen, it is 14. If it is oxygen, it is 16. So like that, we have to take the molar mass. Then we have to find out the number of moles. Number of moles is nothing but the percentage composition divided by molar mass. So just divide these two numbers. If you divide these two numbers, you will get 4.04 and the corresponding values here. Fourth column is over now. Now next we have to find out the ratio. To find out the molar ratio, so you divide all these numbers with the least number given among those three. So when you compare 4.04 and 2.021, 2.021 is the least number. So you divide all of them with the least number and we are getting a value 2, 1 and 1, right? So that is the simplest whole number ratio for the system. So in the empirical formula, we have 2 hydrogen and 1 carbon and 1 chlorine. That's all. So the empirical formula will be CH2 and Cl. Okay. So this is how we have to find out the empirical formula from the given species. Got it? Now coming to the limiting reagent. So the one which is present in very lesser amount in the reactant is called as limiting reagent. Suppose you can see here, 5 hot dogs are given to you and it is reacting with 4 buns. But we have 5 hot dogs and we have only 4 buns. So what can be the product? We can get only 4 hot dog bun and 1 hot dog is left over. Okay, now bun is the limiting reagent and hot dog is the excess reagent. One of the hot dog is the excess reagent. So the one which is present in very lesser amount is called as limiting reagent. Okay. Now I will show you the concentration terms. So these are very important. So we do have some 7 concentration terms. Concentration is nothing but the strength to define a particular thing. So if the concentration term is mass percentage, then we have to use the formula mass of the solute by mass of the solution into 100. And if it is volume percentage, mass of solute by volume of solution into 100. If it is volume by volume percentage, it is volume of the solute by volume of the solution into 100. And if it is molarity, molarity is very important. Molarity is number of moles of solute by the volume of solution in liter. And molality is also again very important. It is number of moles of solute by mass of solvent in kilogram. Okay, capital M, small m. Now coming to the fifth concentration term, it is mole fraction. Number of moles of that particular component divided by the total number of moles. Okay, number of moles of the particular component divided by the total number of moles. Suppose if you're having 3 component, and if I want to find out the mole fraction of A, mole fraction is denoted by the letter X. Okay, if I want to find out XA, what I have to do? Number of moles of A divided by total number of moles, that is Na plus Nb plus Nc. That is what is given here. Okay, so this is how we have to find out. And parts per million, ppm of a solute in a solution is equal to mass of solute by mass of the solution into 10 power 6. So these are the 7 formulas which you have to keep in mind to solve the questions based on the mole concept. Okay, and I will give you some 3 formulas to find out the number of moles from the given system. Okay, so if mass is given to you, in the question, then to find out the number of moles, you have to use the given mass by molar mass formula. Okay, very important. And from the number, if you want to find out, the number of moles can be equal to number of atoms or molecules divided by Avogadro number. Na is Avogadro number. Okay, and in terms of volume, number of moles is equal to the given volume in liter at STP or NTP divided by 22.4. Okay, so these are the formulas to find out the number of moles. Now, based on this, we will solve some previous year questions related to this. Okay, so the first question that I'm going to take for you is the number of units which are used to express the concentration of solutions from the following. So we have mass percent, mole, mole fraction, molarity, ppm, and molality. So which are the terms are being used to define the concentration, to express the concentration? Just now we have seen, right? So mass percent is the concentration term. Mole is not the concentration term. Mole fraction is the concentration term. Molarity, ppm, parts per million, molality. So all these 5 terms are the concentration term which are used to express the concentration of the solution. So the answer is 5. So 5 units are used. Okay. Now coming to one more question. Zinc reacts with hydrochloric acid to give hydrogen and zinc chloride. The volume of hydrogen gas produced at standard temperature and pressure from the reaction of 11.5 gram of zinc with excess HCl is dash liter. Molar mass of zinc is given and molar volume of hydrogen at STP is 22.7. So we have to find out the volume. We have to find out the volume of the hydrogen gas produced. We have to find out the volume of the hydrogen gas produced. So to solve this question, let me write the reaction first. So here zinc is reacting with HCl to produce zinc chloride and H2. H2 is evolving. So if I want to balance this, I have to put 2 here. Okay. Now to find out the number of moles is equal to the given mass divided by molar mass. Right. So what is the given mass? The given mass of zinc is 11.5 and the molar mass of zinc is 65.5. Okay. Here 1 mole of zinc is giving 1 mole of hydrogen. So this is the number of moles of zinc and this much moles of H2 will be evolved. This much moles of H2 is evolved. Okay. Now, the number of moles can be calculated also from the molar volume of hydrogen divided by 22.7. At STP, in the question, it is given as 22.7. Right. Now, if I want to find out the volume, now take this 22 to the other side. Number of moles is 11.5 by 65.4 into 22.7. If we solve this, we will get the volume as 3.99 liter. 3.99 liter. Okay, so this is the volume of hydrogen gas produced at STP. Okay, so two formulas we are using. Both are number of moles related formula. Okay, one is this and the other one is this. So it's very easy, right? So we will move on with the next question. On complete combustion, 0.492 gram of an organic compound gave 0.792 gram of carbon dioxide. The percentage of carbon in the organic compound is. Now, how to find out the percentage of a species? So, to find out the percentage, we need to find out the mass of that particular component. Here, the component is carbon divided by the total mass, right? So, the formula to find out the percentage of carbon in the organic compound, it will be equal to the mass of carbon. It is a formula. Mass of carbon divided by the total mass of the organic compound into 100. Okay. So, we have the total mass. We have the total mass of an organic compound. This is the total mass. But we don't have the mass of carbon. So, we have to find out the mass of carbon, right? So, the mass of carbon in 0.792 gram of carbon dioxide, it will be equal to the atomic mass of carbon is 12 divided by total mass of carbon dioxide is 44 into 0.792. So this will give you 0.216. So this is the mass of carbon. Now substitute this here. Mass of carbon is 0.216 and the total mass is 0.492 into 100. Okay, it will be equal to 43.90 percentage. Mass of carbon in the organic compound is equal to 43.90 percentage. So this is the formula that we are using. Okay, mass of the component divided by total mass of the component into 100. Mass percentage formula we are applying here. JNV Nisumabad students, good evening. So we will go with the next question. The number of hydrogen atoms per molecule of a hydrocarbon A having 85.8% carbon is. So, percentage of carbon is given in the hydrocarbon. But you need to find out the number of hydrogen atoms present per molecule. So, the molar mass of this hydrocarbon is given. So, it is molar mass is given as 84 gram per mole, right? So, hydrocarbon contains carbon as well as hydrogen. Now, what we need to do, we have to find out the mass of carbon in 1 mole of the compound A, organic compound A. So, it will be equal to the mass of carbon is 85.8%. No? So, just divided into the molar mass. So, this will give you 72 gram. So, 72 gram of carbon is present in 1 mole of A. Okay. Now, to find out the mass of hydrogen in 1 mole of A would be, the total mass is 84. In 84, if we subtract the mass of carbon, we will get the mass of hydrogen, right? It is 12 gram. From the total mass, subtract the mass of carbon, you will get the mass of hydrogen, which is 12 gram. Now, to find out the number of hydrogen atoms present in a molecule of A, it will also be equal to 12. Therefore, the number of hydrogen atoms in a molecule in 1 mole, right? So the one in 1 molecule of A, we will have 12 atoms of hydrogen. Okay. Now moving on to next question. The volume of hydrogen liberated at STP by treating 2.4 gram of magnesium with excess of hydrochloric acid is dash into 10 to the power minus 2 liter. Molar volume of gas is 22.4 at STP. Molar mass of magnesium is 24 gram. So we have to find out the volume of hydrogen liberated. It is same as that of the previous question, right? So here magnesium is reacting with the 2HCl to produce MgCl2 and H2. If I want to find out the number of moles, it is given mass divided by the molar mass. The given mass of magnesium is 2.4 and the molar mass is 24 for magnesium, and this will give us 0.11. So the number of moles is 0.1. We all know that 1 mole of gas at STP is equal to 22.4 liter. Now the number of moles is 0.1. So 0.1 mole of gas at STP will be equal to 0.1 into 22.4 divided by 1. Right? So this is equal to 2.24 liter. And we can also write this as 224 into 10 to the power minus 2 liter. Okay. So the answer will be 224 into 10 to the power minus 2 liter. Okay. This is how we have to calculate. And moving on to one more question. 50 liter of nitrogen, 56 liter of nitrogen gas is mixed with excess of hydrogen gas, and it is found that 20 liter of ammonia gas is produced. The volume of unused nitrogen gas is found to be dash liter. So for this, we have to take the reaction. So this is Haber's process, where N2 reacts with 3 moles of H2 to produce 2 moles of NH3. Okay, and here you can see that 1 mole of nitrogen is giving 2 moles of ammonia. So in the question it says that 20 liter of ammonia is produced. If I want to get 20 liter of ammonia, then 10 liter of N2 must have reacted, right? But in the vessel we are having 56 liter of nitrogen gas, but only 10 liter have got reacted. So the volume of nitrogen left in the reaction would be, so it is already 56 and 10 has got reacted, remaining 46 liter is left. The volume of unused nitrogen gas is 46 liter. Very easy, right? JEE 2022 question. Yeah. So we will go with one more question. The 2 elements A and B, which form 0.15 moles of A2B and AB3 type compounds. If both the compounds weigh equally, then the atomic weight of A is dash times of atomic weight of B. So we have 2 compounds and the molar mass, atomic weight, molar mass of A to B should be equal to AB3, right? Because they weigh equally. Molar mass should be equal. So therefore, 2A plus B, here in the left hand side, it should be equal to A plus 3B, right? So just bring this here. 2A minus A will be equal to 3B minus B. So it is A which is equal to 2B. So the answer is 2. Correct answer is 2. So the atomic weight of A is 2 times of atomic weight of B. Okay. Yes. Coming to the next question. The moles of methane required to produce 81 gram of water after complete combustion is dash into 10 power minus 2 mole. So we have to write the combustion of methane first. So the reaction is CH4 plus 2O2 giving CO2 plus 2H2. So this is the complete combustion reaction of methane. We need to find out the number of moles of methane required to produce 81 gram of water. So here 1 mole of methane is producing 2 moles of water, right? So 2 moles of water means for 1 mole of water 18 gram is there. 2 moles means 36 gram, right? 36 gram of water is coming out for 1 mole of CH4, right? But 81 gram of water needs 1 into 81. This cross multiply divided by 36. So this much mole of CH4 is required. So it will be equal to 2.25 volt. Or we can say that 225 into 10 to the power minus 2 mole. Okay, 225. So for 1 mole of H2O, we have 18 gram. For 2 mole of H2O, 18 into 2, right? So it is 36. We are finding out for 36 gram, but in the question they are asking for 81 gram. So just cross multiply and get the answer. Okay. So now one more question. CNG, compressed natural gas, is an important transportation fuel. When 100 gram of this compressed natural gas is mixed with 208 gram oxygen in vehicle, it leads to the formation of carbon dioxide and water. Carbon dioxide and water is coming out means it should undergo complete combustion, right? And they are produced large quantity of heat during this combustion. Then the amount of carbon dioxide produced in grams is. So we have to assume this compressed natural gas to be the methane gas. Okay. Then we have to write the complete combustion reaction of methane. So it will be again CH4 plus 2O2 giving CO2 plus 2H2O. Okay. Now the weight of CH4 compressed natural gas is 100 gram. And this is the gram of oxygen. So the weight of oxygen is equal to 208. To find out the number of moles of oxygen, so number of moles is mass by molar mass, right? So the given mass is 208 and the molar mass of oxygen is 32. But here 2 moles of oxygen is reacting. So 2 into 32. Should be 2 into 32. So it will be 64. And if we solve this, we will get 3.25. This is the number of mole of oxygen. Okay. If I want to find out the number of moles of CH4, the given mass is 100 and the molar mass of CH4 is 16. So it will give 6.25. So from these two values, we can say that the one which is present in with very lesser amount is limiting reagent. So the oxygen is the limiting reagent. So O2 is the limiting reagent for this reaction. So now based upon the availability of oxygen only, the reaction occurs. So here in the reaction, 2 moles of oxygen is producing 1 mole of carbon dioxide. Okay. So 2 moles means it is 3.25, right? So 3.25 is the number of moles of oxygen, which is equal to the number of moles of carbon dioxide. Okay, this is the number of moles of carbon dioxide. Now we all know that number of moles is mass by molar mass. Now the mass will be equal to the number of moles into the molar mass. Number of moles of carbon dioxide is 3.25 and the molar mass of carbon dioxide is 44, right? For carbon it is 12 and for O2 it is, for 1 oxygen it is 16, for 2 oxygen it is 32. 32 plus 12 is 44 and this will give us 143 gram. Okay. We are finding out the mass of carbon dioxide. Mass of the amount of the carbon dioxide produced in grams using mass by molar mass formula. To find out the number of moles, we are going with number of moles of oxygen. Okay. This is how we have to proceed with this. Then coming to one more question. The number of nitrogen atoms in 681 gram of C7H5N3O6 is x into 10 to the power 21. The value of x is, the Avogadro number is given. So, I need to find out the molar mass. The molar mass of C7H5N3O6, it is equal to, so we can calculate, right? So carbon atomic mass is 12, and for hydrogen it is 1, and for nitrogen it is 14, and for oxygen it is 16. If we calculate with the corresponding numbers like 7 into 12 plus 5 into 1, and with the 3 into 14 and 6 into 16, we will get the molar mass as 227 gram per mole for this compound. Okay, 227. But here 681 gram of this is there. 681 means 681 gram of C7H5N3O6 is equal to, this is 1 mole and this is for 3 mole. In 1 mole we have 3 nitrogen. In 3 mole what we have to do? 9 nitrogen will be there, right? 3 into 3. So the 681 gram of this compound has 9 moles of nitrogen, which will be equal to 9 into the Avogadro number, 6.02 into 10 to the power 23 nitrogen atoms are present in this 681 gram of compound. Okay. Now, if you multiply, you will get 54.18 into 10 to the power 23 nitrogen atoms, which is equal to 5418 into 10 to the power 21 nitrogen. Okay. So 681, 3 into 227 will give you 681. So 3 moles. In 1 mole we have 3 nitrogen. In 3 mole we have 9 nitrogen. And the number of nitrogen into the Avogadro number will give us the value of X, the number of nitrogen atoms. Okay. Fine. Now coming to the next question. The number of atoms in 8 gram of sodium is X into 10 to the power 23. The value of X is. So the mass of sodium is given. We have to find out the number of atoms. So we know that the number of moles is equal to number of atom divided by Avogadro number. Or I can say N0 or Na. And the number of moles is also equal to the given mass divided by molar mass. So both are the formulas to find out the number of moles. Let me equate these two formulas. Now the number of atom divided by Avogadro number, it is going to be equal to the mass of sodium. 8 gram divided by the molar mass of sodium is 23. So if I cross multiply, I will get the N value as 2 into 10 to the power 20. 2 into 10 to the power. The value of the X is 2. So just equate the number of moles formula and get the answer. Very easy. So this N is nothing but the number of atoms or molecule, and Na is the Avogadro number. This is the given mass in the question, and this is the molar mass of the compound. Okay. Okay. So we will do one more question. If 80 gram of copper sulfate is dissolved in deionized water to make 5 liter of solution, the concentration of the copper sulfate solution is X into 10 to the power minus 3 mole per liter. The value of X is. What we have to do? We have to find out the concentration. Here the concentration is given in terms of mole per liter. So mole per liter is the unit for molarity. So we have to find out molarity. So what is molarity? Molarity is equal to number of moles of solute divided by volume of the solution in liter. Number of moles can be again calculated by mass by molar mass into the volume of solution in liter. So what is the given mass of the substance? The given mass copper sulfate is 80 grams. So the given mass is 80 gram. And the molar mass of this component, this copper sulfate and pentahydrate, if we calculate the atomic mass, if we add the atomic mass and if we try to calculate the molar mass, we will get 249.54. And the liter is, volume is 5 liter. And on calculation, we will get 64 into 10 to the power minus 3 mole per liter. So 64 is the value of X. Just apply the components in the formula. That's all. Very important. Okay. Clear? So now we will go with the next question. The molarity of the solution again prepared by dissolving 6.3 gram of oxalic acid in 250 ml of water in mole per liter is X into 10 to the power minus 2, the value of X is. So again, mass is given, volume is given in terms of milliliter. We have to find out the molarity. So again, first the molar mass. Let me go with the molar mass of this oxalic acid. If we calculate the molar mass of this oxalic acid, we will get 126 gram per mole. Okay. Now substituted in the molarity formula. Molarity is equal to number of moles of solute divided by volume of solution in liter. Number of moles is mass by molar mass. The given mass is 6.3 and the molar mass is 126 and the volume is 250 milliliter. So it is 250 divided by 1000, right? So that 1000 goes to the numerator. So if we solve this, we will get 6.3 into 4 divided by 126. It is equal to 0.2 molar. Or I can write like it is equal to 20 into 10 to the power minus 2 mole per liter. So here the value of X is 20. Okay. Again, the same molarity substitution. Got it? Now moving on to one more question. The percentage composition of carbon by mole in methane is. So methane is CH4 and we have to find out the percentage by mole carbon. Percentage composition of carbon by mole. So percentage by mole of carbon, it will be equal to, so in methane we have 5 atoms, so 1 carbon and 4 hydrogen, right? So carbon is 1, number of atom is 1, carbon atom is 1 and the total atoms, they are 5 into 100. So 100 by 5 is 20%. So we have 20% of carbon in methane and the remaining 80 is hydrogen. Very easy, direct substitution of the formula. Okay. And coming to the next question, 8 gram sodium hydroxide is dissolved in 18 gram of H2O. Mole fraction of NaOH in solution and molality of the solution respectively are. So here, to find out the molality and the mole fraction, so to find out the mole fraction, of NaOH, we need to find out the number of moles of that NaOH. Let me take this NaOH as A and H2O as B. Okay. If I want to find out mole fraction of NaOH, it is Na by Na plus Nb. So to find out that, we need to find out the number of moles. So what is the number of moles of A? Number of moles of A is mass by molar mass. And the mass of NaOH is 8. Molar mass of NaOH is 40. For sodium, atomic mass is 23. And for oxygen, it is 16. And for hydrogen, it is 1. If we add all these things, we will get 40. So the number of moles is 8 by 40, which is equal to 0.2 mole. And the number of moles of B, that is water. The given mass of water is 18 gram. And the molar mass of water is also 18. So it is equal to 1 mole. So here is the number of moles. We can substitute here. So Na is 0.2 and Na is 0.2 plus 1. Okay. So 0.2 divided by 1.2 we will get. Okay. So we will get 2 by 12, which is again equal to 1 by 6. So this is the mole fraction of NaOH. And also we have to find out the molality. How to find out the molality? Molality is equal to the number of moles of solute divided by the mass of solvent in kilogram. Okay. So the number of moles of solute is 0.2. Okay. And the mass of the solvent is 18 gram. But we have to substitute in kilogram. So it should be divided by 1000. So that 1000 goes to the numerator. So on solving this, we will get 11.11 molal. Okay, the molality is 11.11. So it is a concentration term. Okay, so I will go with one more question. The amount of sugar required to prepare 2 liters of its 0.1 molar aqueous solution is. So here you see the concentration is given in terms of capital M. Means it is molarity. This molarity and volume is also given. We have to find out the amount. Amount means we have to find out the mass. So what is the formula which relates the molarity and number of moles? Molarity is equal to the number of moles of solute divided by the volume of solution in liter. Number of moles is equal to mass by molar mass, and volume is already there. Okay. So now the given mass only we have to find out. Mass is not given. So this is what we have to find out. So this is the amount. Mass is the amount that we need to find out. Okay, molarity is given. So molarity is 0.1 and we have to find out the amount, that is mass, and the molar mass of sugar. If you calculate 12 into carbon, right? Its atomic mass of carbon is 12 and 22 hydrogen is there, 22 into 1. And for oxygen, it is 16. Atomic mass is 16 and 11 oxygen. And if we calculate, we will get 342 gram per mole as the molar mass of this sugar. And the volume of sugar is 2. Okay, now just substitute this. And you will get 0.1 into 342 into 2. So we will get 68.4 gram as the mass. As the amount of the sugar required. 64.4 gram of sugar is required to prepare the 2 liters of its 0.1 molar aqueous solution. Okay. So this is how we are getting the answer for this. Now coming to one more question for today. For the following reaction, the mass of water produced from 445 gram of C57H110O6. So reaction is given. We need to find out the mass of water produced. Here, the mass of water produced from this particular gram of compound. Okay. So here in this reaction, you see 2 moles of this compound is reacting. So the molar mass of 2 moles of C57H10 and O6. It will be equal to, if we calculate with the atomic mass of carbon, hydrogen and oxygen, and if we try to calculate the molar mass of each thing, and then on multiplying this by 2, we will get 1780 gram. Okay, this is the molar mass of 2 moles of this component. Now next I want to find out the molar mass of 110 moles of this water. It is equal to 1110 into, for hydrogen it is 2 and for oxygen it is 16, right? So this will give us 1980 gram. Okay, so 1780 gram of C57H10O6 gives 1980 gram of water. Okay, but 45 gram of the given compound would result in, let's cross multiply, 1980 into 445 divided by 1780. Okay, this much gram of water will come out. So it will be equal to 495. So 495 gram of water is produced from the given reaction. Okay, we are finding out the molar mass and then we are cross multiplying and getting the answer. Okay. So this is about this. And moving on to the last question for today's session. This is the last question. So for this particular reaction, we need to find out in which reaction the dihydrogen is acting as a limiting reagent. So what is a limiting reagent? The one which is present in very lesser amount is called as limiting reagent. So let's start with option A. So let me write the reaction first. It is N2 plus 3H2 giving 2NH3 reaction, right? So the atomic mass of nitrogen is 14 and we have two nitrogen. So 2 into 14, it will be equal to 28 gram. So 28 gram of nitrogen is reacting with 3 into 2, 6 gram of hydrogen and 2 moles of NH3 is coming out. So 2 into atomic mass of nitrogen is 14 and for each hydrogen it is 1. We have 3 hydrogen, so 14 plus 3. So it is equal to 34 gram. So 28 gram of nitrogen is reacting with 6 gram of hydrogen to produce 34 gram of ammonia. Okay. So 28 gram of nitrogen requires how many mole of hydrogen? Requires 6 gram of hydrogen gas. Okay. But in option A, if you see 56 gram of nitrogen requires 6 into 56 divided by 28. It will be equal to 12 gram of hydrogen. Okay. So for 56 gram of nitrogen, we need 12 gram of hydrogen. But here in this option, you see, for 56 gram of nitrogen, only 10 gram of hydrogen is given. 10 gram of hydrogen is given. So hydrogen is present in very lesser amount. So that is the limiting reagent. Hydrogen is the limiting reagent in option A. So we can directly go for that option as the correct option. Okay. So the required amount is not present. It is present in very lesser amount. So hydrogen is a limiting reagent in option A. That is the answer. We can check for other components also. Okay. If I am going for this, the other option, we will have 6 into 35 divided by 28. Okay, we will get some other answer which will be lesser than this 8 gram. Okay. So option A is the correct answer for this question. So with this, I'll end of the session. So I hope this session is very clear and useful to all of you. We have seen some formulas in the beginning and we have solved the previous year's questions of JEE and NEET. Okay. So in next session, we will meet up with some more questions and theories. Okay. Thank you all so much for listening to the lecture. Thank you.